Cache memories reside in the middle of memory hierarchy, below registers and above main memory. Physically, they exist inside the CPU, so they are on-chip memories. They hold blocks of data or instruction retrieved from main memory. Cache memories are small, fast, SRAM-based on-chip memories managed automatically by hardware, and they act as a staging area for a subset of data in a larger, slower main memory. During program execution, they hold frequently accessed blocks from main memory. Modern processors have multiple levels of cache, mostly 3 levels, L1, L2, L3. CPU first looks for data in caches, then in main memory, that is L1 first, L2 next, L3 next, and then main memory. Let's visualize the interaction among different cache levels and main memory. This is a very simplified simulation where a cache holds only 4 cache blocks or cache lines. When CPU requests the data or instruction, the block that has that is copied from main memory to cache. If cache is full, then the cache selects a victim block and evicts. In this example, block 8 is evicted by block 4 and block 14 is evicted by block 10. Let's talk about cache hit. When cache has the item that CPU requests, it immediately returns it to CPU without looking for low memory hierarchy, and it is called cache hit. In this example, CPU requests data in block 14 and cache has block 14, so it's a cache hit and we don't have to access slow main memory. Let's talk about cache miss. When cache doesn't have the item that CPU requests, it has to access low levels of memory hierarchy to get the block, and it is called cache miss. In this example, CPU requests data in block 12, but the cache doesn't have it, so it is cache miss and we need to access slow main memory to get the block 12. As the new block 12 is being brought into the cache, we have to select the victim cache block, and cache has a replacement policy to select the best victim candidate. Here's a simulation. There are 3 types of cache misses. It's called 3 C's. First type is cold miss, also known as a compulsory miss. Cold miss occurs when we access the block for the first time, and because the cache is empty, it causes a miss. The second type is conflict miss, and it happens because a certain cache configurations limit where a block can be placed, and because of this, an existing block has to be evicted even though the cache has other empty slots. Third and last cache miss is a capacity miss. It occurs when the set of active cache blocks, also known as a working set, is larger than the cache. This type of cache misses can be fully avoided if we increase the cache size.